A good day to our lecturer, Dr. Muhammad Akramin. So, for today, we are from Group 2. We'll be presenting on the lab report 9, rolling this on inclined plane. Okay, my name is Matthias Azam of matrix number MA19129. So, for today, I'll be presenting on the introduction part. Okay, firstly, this group consists of 5 members, Muhammad Hazam, Muhammad Badr Amin, Muhammad Ashraf Iqmal, Muhammad Ashraf Sofi, and me myself. Okay, so for the introduction part, this part will be divided into 2 parts, which are free fall and inertia. Okay, firstly, free fall. In free fall, a body can travel freely in any direction within the gravitational field. To begin with, a free-falling body experiences constantly constant movement in close proximity to the Earth when the mentioned resistance is minor in relation to the body's weight. This is as discovered by Galileo. Okay, so there are 2 key movement features that every item in freefall has in common. Okay, firstly, free-falling bodies do not produce any air resistance, and the second one is free-falling objects on Earth accelerate their descent at 9.8 meter per second square, which is this is used to calculate a speed of 10 meter per second square. And then, for your information, a free-falling object's speed is precisely proportional to the height from which it drops. So, the free fall formula is v squared equal to 2gh, where v equals to final velocity, g gravity, and h is height. Next part is inertia. Okay, inertia. The moment of inertia is the amount of resistance a body exhibits when its rotational speed around an axis is altered by applying a torque twisting force. Okay, so for this, all bodies, whether at rest or traveling in a straight line, have inertia, which is responsible for their movements. So, as a result, these actions are described using the law of inertia. Okay, for your information, Newton's law of inertia states that if no external forces are applied to a mass, it will remain stationary or move in a straight path. Next is angular mass. Angular mass is also known as rotational inertia. It determines how much torque must be given to a spinning object in order for it to accelerate. Okay, so the moment of inertia is calculated by multiplying each particle's total quantity of the product of mass by the square of its distance from the axis of rotation. This is depending on the object's distance from the spinning axis, and it has numerous moments of inertia. Thus, the moment of inertia in this formula is as stated below. J equals to 12 mr squared. I think that is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badr Amin Berazak, and my metric number is MA19082. Okay, now we present about experimental setup and procedure. For experimental TM611 rolling disc on inclined plane apparatus, which is comprises of 2 carrier which 3-point bearings serve as the inclined plane. Second, a height adjuster to adjust the angle of inclination. Third, angulometer to gauge the angle of inclination. So at home we just use protector. Fourth, a meter stick to gauge the distance. We just use ruler. To this self-centering by means of conical shaft joiners, we use the ping pong ball. And 3 bubble level for precise element. We don't have that at home. And 7, a pendulum support. 8, base plate. 9, roll. And 10, stopwatch. Okay, now we go to the experiment number 1, which is experiment inclined plane. So the procedure for experiment inclined plane: first, set the inclined plane desired inclination. Second, choose the distance between 0 and 1000 mm, which the meter stick and start the stopwatch. Third, set the required ping-pong ball in the track 0 position. Ascertain that the rotational axis midpoint is at the marking and the ping-pong ball is in the center. 4. Remove the ping-pong ball and begin the stopwatch. Stop the watch when the ping-pong ball reach the desired distance. Make the watch is only stopped when the midpoint of measuring mark is been reached. Fifth, to reduce measurement mistakes, repeat the measuring method numerous times. Then, for each set of experiments, compute a mean value and record the result in the table 1, 2, and 3. So, next, this is the example we made the experiment at home. So, we can see this. Okay, next, this is the formula for the experiment number 1. Okay, now we go to the experiment number 2, which is experiment test pendulum support. For the procedure, first the pendulum support and base must first be connected. Second, to aid with leveling, a box lever is affixed toward the base plate. Third, tighten the star grip screw until the bubble in the bubble lever is in the precise center spot. These nuts are being used to secure the star grip screws. 4. Insert the horizontal pin provided in the disc to be rotated. 5. Place the disc in the pendulum support and tighten it. 6. Swinging the disc and checking the number of oscillations such as 10. 7. Calculate the minute depending on time, mass, and distance from the center of the gravity. So, in the report you can see the table 4, the result of the initial test. And next, this is the formula for the experiment number 2, which is T equal to 1 over F, which is 1 over frequency. So, formula ni, omega equal to 2 pi F and Js equal to m dot g dot s over omega squared minus m dot s squared, which is T for the period, F for frequency, omega for angular velocity, Js for moment of inertia, G for acceleration due to the gravity, and S this radius. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf Sofi and my date number is BMM2521. So now I will continue presentation with the result. For test 1 incline plane, this is the angle of inclination starting from 1 until 7. This is the result of average of roll time for the distance of 1000 mm. So which part is large disc and small disc. So next is result for the table 2 for the large disc. So we count the acceleration, calculated time, measured time, and deviation. And lastly, in the table 3, we use the small disc and calculate the roll time for the distance of 1000 mm with the angle of 1 until 7, and we got the deviation. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazam bin Zahri. I will continue with test 2, which is pendulum support. From this table, we can see the results are divided into two, which is large disc and small disc. For large disc, T1 we get 2.64, T2 2.62, and T3 2.54. And for Tmin 2.6, omega 2.39, last one joule, we get 0.011. For small disc, T1 we get 1.93, T2 1.56, T3 1.63, and Tmin 1.71, and omega 3.64. Lastly, for joule, 2.32 multiply 10 power of negative 3. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Arwin, metric number MA19126, and I will be presenting the discussion for this experiment. The discussion consists of 13 questions. The first one is how to adjust the angle of inclination. The answer is, in order to adjust the angle of inclination, turn the height adjuster spindle until the desired value is shown. The second question, what is the purpose of an angulometer? The, the answer is, the purpose of the angulometer is to determine the angle of inclination so that we can set up our experiment within the constraints. Third question, can you give an alternative method to measure the angle of inclination? The answer is, another method to measure the angle of inclination are through trigonometry method or using the protractor. The next question, how to make a precise alignment for the experiment. Do the experiment on a flat surface to avoid angle of inclination mistake. The angle of inclination can be measured with protractor. Next one, why the angle higher than 7 cannot be used for the experiment? The answer is, if the angle is more than 7 degrees, the disc will slip at high speed, causing the static force to be insufficient to maintain the acceleration, affecting the experimental findings. The sixth one is, give the definition of free fall theory, which was discovered by Galileo. The answer is, a movement is said to be evenly accelerated when it acquires at some point, starting from rest, similar interval, identical speed increments in close proximity to the Earth. A free-falling body accelerates evenly, and air resistance is insignificant in comparison to the weight of the frame. The next one, give the factors that cause a free-falling body. The absence of air resistance, gravity, and controllable factors such as high angle, speed of release, and weight can all attribute to the falling. What is the relation between angle of inclination and the rolling disc? The angle of inclination will directly affect the velocity of the rolling disc. The larger angle of inclination, the higher velocity of the rolling disc will have. The ninth one, explain the term inertia. Inertia is the property of an object to resist any change in its state of motion or in rest, including changes to its speed and direction. Why repeatability of the measurement is important? It is to minimize measuring error. For this, the average measured time is utilized. The next one, draw free body diagram of the disc roll on an inclined plane. As you see in the picture below. Next one, why deviation occurs between calculated and measured value. This is because of material qualities such as friction. There is difference between when we release the tape to roll and accidentally apply external force. The last question is, suggest improvement of the experiment. The experiment instrument can be properly prepared to avoid a larger variance in the outcome. Finally, make sure the experiment surface is flat to avoid inclination angle mistakes. That's all from me. We will move to the conclusion.
And now I'll be presenting on the conclusion part. Okay, so to conclude, the time it takes for the disc to roll down the plate is determined by the disc weight. According to Newton's second law formula, acceleration is equal to net force divided by mass. And for your information, if the disc is heavy, it will accelerate slowly. So, based on Newton's first law, the Planck angle and Newton's second law may also be used to define acceleration. The second law states that the acceleration of an atom is proportional to its net force. And I think that is all for me. Thank you.